question is express each number as the product of its prime factors. In this question we have been given these 5 numbers, that is in 5 parts we have been given these 5 numbers, and we have to express each number as the product of its prime factors, right? So to solve this question, taking the first part, the number is 140. So whenever we have to convert a given number into its prime factor, first of all we see that the number is even or odd. So 140 is an even number. So first of all we keep on dividing the number by 2, so till we get the number as equal to odd. Okay, and then we are going to take other prime numbers to convert it into its prime factor. Okay, so dividing 140 by 2, this will be 70. Further dividing by 2, I'm going to get this as equal to 35. 35 ends with 5, so it is divisible by 5. So dividing it by 5, 7 5s are 35. 7 divided by 7, I get 1. So you see, I progressively divide the number. I continuously divide the number by prime number so that I obtain the quotient as equal to 1. And when I obtain the quotient equal to 1, then the product of the divisors will be the prime factors. So prime factors of 140 will be equal to 2 into 2 into 5 into 7, or 2 square into 5 into 7. Okay, so this is the answer for this first part, 140. In second part, I have been given 156. It is an even number. So I begin it by dividing it by 2. So this will be equal to 78 as quotient. Further dividing by 2, I'm going to get this as equal to 39. 39 is divisible by 3. So I divide it by 3. Okay, so quotient is 13. 13 is again a prime number, dividing this by 13. So I get the quotient as equal to 1. So the prime factors of 156 are 2 into 2 into 3 into 13. Okay. Or this can be written as 2 square into 3 into 13. In the next part, that is in the third part, I have been given 3825. Okay. So obviously you must have taken out a result in your head that this number is divisible by 5 because it is ending with 5. So we are going to start solving it by dividing it by 5. So dividing 3820 by 5, I get this equal to 765, which is again divisible by 5. So further dividing it by 5, I'm going to get this as equal to 153. 153 is divisible by 3. So dividing by 3, I'm going to get this as 51. 51 is again divisible by 3. I get this as 17 as quotient. 17 is a prime number. So dividing this by 17, I get this as equal to quotient as equal to 1. Therefore, prime factors of 3825 is equal to 3 into 3 into 5 into 5 into 17, or 3 square into 5 square into 17. In the fourth part, I've been given 5005. So again, this number is ending with 5, so it is divisible by 5. So we are going to start converting it into prime factors by dividing this number by 5. So dividing 5005 by 5, I get this as equal to 1001. 1001 is divisible by 7. Look here, you must be thinking that how can I see that this number is divisible by 7? Okay, so we have to check whether the number is divisible by 2, 3, 5 and 7, and progressively we keep on increasing that which prime number divides the given number. Okay, so it is just a matter of calculations. Okay, so it is a time consuming activity. You have to check, only way you can see that a given number is divisible by a number by knowing the divisibility test of the number. For example, this number 5005 was divisible by 5 because it is ending by 5. Anyone can say that this number is divisible by 5 after knowing that a number ending with 5 or 0 is divisible by 5. But we do not know the divisibility test for 7, so we have to keep on checking. Okay, so dividing 1001 by 7, I get this as equal to 143. Okay, so 143 is divisible by 11. So quotient is 13. Further, dividing 13 by 13, I get this as equal to 1. Therefore, prime factors of 5005 is equal to 5 into 7 into 11 into 13. Okay. Now, this one is a bit difficult value, 7429. Okay, so to convert into prime factors, we keep on dividing this number by 3, 5, 7 and so on till we obtain that this number was divisible by 17. Okay, so when a number is divisible by 17 and not divisible by the smaller prime number, so this means that the quotient which will be remaining would be divisible by a prime number equal to 17 or greater prime number. Okay, so dividing this by 17, I'm going to get this as equal to 437. So I'm going to further check that this number is divisible by 17 or not. So 17 2s are 34, 97. No, it is not divisible by 17. So I'm going to take the greater prime number. So on taking 19, this number was divisible by 19. So the quotient is 23. 23 is again a prime number. So I get a quotient equal to 1. So prime factors of 7429 is equal to 17 into 19 into 23. So this completes the solution of the question. Thank you. Please support us by subscribing to our channel, by liking this video and giving your comment for the video.